Right. So my name is Aleksandr. I'm more than 10 years in IT. Currently, I'm engineering manager at Yandex Cloud, but for past 3 years, I was in reliability as a tech lead in fault injection testing in Yandex Go. So a few words about Yandex. Okay, so today we will talk about criticality tiers and how they can be used for great good. So a few words about Yandex to give you context about our company. Basically, we search company with a lot of different services, and one of well-known is Yandex Go, Yandex Mail, Yandex Maps, Yandex Search, Yandex Cloud. But I will talk from Yandex Go perspective, so it's important to give some context about our system. So here's a network about which shows services and connections between them. In the nodes are services and connections, well, links are connections. In total, there are more than 1,000 of microservices, which supported and developed by more than 800 of developers. This system used by different business units. I will use this word in my talk, by Yandex Go, by scooters, and by other business units, more than 5 in common. And for Yandex Go, we have so-called core business value, also known as key business value. Since we are a search company, we find driver for passenger, we find passenger for driver, and we provide technical capability to start trip. So that's our core. Other features, well, features. And we quite different from enterprise, from different enterprise companies. We don't have central product architects. We instead delegate product architecture to team. They can design by themselves which database to use, which queue to use, which integrations to use, which language to use. So teams quite autonomous here. But we have central arc review for some processes. When a new microservice is created, we ask them maintainer to pass arc review to describe what this service does and so on. And for some complex technical problems, mainly for removing monolith and implementing new protocols and something like that. So criticality tiers, it is a way to define how microservice is critical for business. And the focus resource distributions. We have 4 different tiers, from most critical to less critical, A, B, C, and D. And with great tier comes great responsibility. So you can ask why we can't use just technical metrics. Please raise your hand who thinks that technical metrics is enough to say that service is critical. Right, so everyone thinks that we need to do something else. So let me show you an example why technical metrics actually not enough. Let's assume we have 3 different services. For first service, we have 1,000 RPS. For second, 50 RPS. And in total, they load third microservice with 1,300 RPS. Please raise your hand who thinks that first service is critical to business. Right. Please raise your hand who thinks that second is critical for business. And please raise your hand who thinks that third one is most critical. Right. Almost everyone thinks that third one is most critical. Please remember your questions, your answer, and I will return back to it. So in these systems, big as a system, we have few problems. Experts leave. If you have strong incident manager who knows everything about the system and how to fix it, how to maintain it, and if it leaves, most likely you will lose some expertise, which leads to increased recovery time and probably discovery time. So it's quite a bad thing, but you can mitigate it in different ways. Sometimes incident happens, sometimes because of microservices, because of bad release, bad deploy, bad configuration, forgotten network access, and all this stuff. And load increases. New features lead to increased load to existing microservices. New clients lead to increased load. So you just have more and more load to your services. And we have hidden factors. Well, not hidden, but quite obvious. Hardware is limited. Even in best world where we have access to all hardware in the world is still limited. You can just apply it all the time. Human focus is limited. You cannot focus developer on multiple services, especially if all of them somehow critical or not. And the human time is limited. Developers should develop features and maintain at the same time, mostly. So we can make some philosophy here and say that we have meta problem, that system is dynamic, and it consists of chaos, and we don't rule this chaos. So to cap that, we can formulate a goal. So we want to manage case, and in our context, we want to prioritize which services are important. But how? Well, in this, my short question, correct answer is not to raise your hand. Why? Because you don't have enough context to that. For example, first microservice can be just a search service which provides you, I don't know, cars on your minimap in application. Third one returns cars colors, and second one actually makes an order happen. So, and it has some fallback if third one goes downtime, so it can work without it. So with this context, probably you would answer that second one is most important for the business, and you will be right. And so we can form from that another problem, the knowledge in our systems. Knowledge often is siloed between different stakeholders, between teams, between incident managers, between technical managers, between architects, if we have them. And all of these stakeholders understand criticality by their own. They have different definitions for it. So to cap up our problem, we have a system which has dynamic nature, people, connections, components, connections between components, and the knowledge about this system. So how we can solve that? We can make some standard. And here we defined criticality tiers. It's a way to say how service is critical for business. And in our first version, we defined key business value. We found that what actually a taxi is. We said, okay, we need to find driver, we need to find passenger, we need to provide capability to start an order, to start the trip, and that's all. That's our key business value. Let's focus on maintaining stability of this feature. And we defined criteria for key business value, which says, okay, if we lose some orders, more than X orders, then it's tier A. If downtime of this service leads to unavailability to make an order happen, so it's tier A. And we found most critical services and said that it's tier A. So, and we added markup in YAML file and placed it next to the microservice code base. So basically it looks like this. In our next iteration, we defined B, C, and D tiers, and we still stick to key business value. And we added time impact. So tier A, actually, if downtime of tier A can lead to loss more than X orders during some time, it's tier A. If we have downtime for other service and we lose orders, different amount of orders for B means it's tier B. At the same time, business units started adopting our practice, but with their own interpretation. We adopted that. We added a new section to service to YAML file, and now we have nested section like that. So we can define a critical tier in different ways. And we found new challenges here. We found that single service can impact few business units, actually. We found it in a fun way. We injected faults to this service. We thought it only affects taxi, Yandex Go. And it went that related business unit went full downtime because they didn't know that it's important for them, that it's critical for them. So we found out that one service can impact multiple business units, and from other side, maintainers started having more cognitive load because of that. We started because one service can be tier B for scooters, tier A for Yandex Go, and so which tier we have in total? It was quite a big problem for us. And we decided that we need some way to manage that. We defined so-called base definition of criticality tiers on very, very high level without any criteria. And it's tied directly to on-call requirements, to reliability requirements, to all this stuff. And business units inherit them with added criteria. So how tier impacts? Well, it impacts on call. For tier A, we require instant reaction time during night and weekends. For tier B, we allow reaction time for 1 hour from incident happened, from incident reported. And for CD, it can wait business hours. Of course, if incident happens during business hours, all tiers should fix it immediately. It also affects reliability requirements. For tier A, we have more strict reliability SLA. For tier D, less strict availability SLA. We have a platform and different frameworks which used in our platform. And we defined that, if we have such thing that as criticality tiers, we roll out from lowest critical services to highest critical services. It can be like operation system upgrade or some security patches and all this stuff. And we have such thing as freezes, as a production change freeze, as architecture freeze, and as changes freeze, and it affects only tier A and B. For all this conception, we have processes how to assign tiers. One of most important things here is to decide by whom tier can be assigned. In our case, we have shift-left paradigm, and we say that service maintainers completely own accuracy of the tier. They need to prove that it has assigned a tier. They need to do some processes to update this tier. And of course, from other side, this change can be requested. This tier can be requested to change from incident managers and from business unit owners. And we have different ways how to do that. If service has no tier, we can ask maintainers, okay, guys, please say which tier you think you have given by these criteria. If it's CD, lowest tiers, they can just update tier and story ended. If it's B tier, then we ask teams to do fault injection testing, fault injection drills. It's a thing where we emulate complete downtime of this service. It just returns internal error or have some latency issues. And if by these drills we found that our system went downtime, then it possibly tier A service, the team should pass arc review and say why they're critical and what way they want to do with that. So we have periodic review. Same thing for different tiers. We have different SLA for drills. For example, for tier B, we do drills once per quarter. For tier C, we have drills once per half year. And for tier D, we drill once per year. So again, we do fault injection drills. If it's tier A, we ask team to do arc review. If not, they just update the tier. And for change request, we ask requestee to bring artifacts. It can be drills, it can be incidents, it can be business needs. But if they don't have artifacts, if they don't have proof that it's actually different tier, they need to go collect something of them to do some fault injection drills again and discuss it with maintainers. If everyone agreed, then okay, they can just update tier. If some parties disagree, then we ask them to go to arc review, describe situation, and the architecture will be as a judge who judges the parties. And we have different process to downgrade from tier A. Basically, maintainers should describe what they want to do to reduce the tier in arc review. After that, implement changes, and after that, prove that they actually not critical by fault injection drills. And after that, they update tier, and basically that's all. For these processes, actually, almost no process works without tools, so we made some tools for that. We have knowledge freshness dashboard. Basically, it shows which services when drilled, how many teams in SLA for drills. As I said, different tier have different SLA. We have deadlines for drills. We have hierarchy view for CTO -1 level to see how many drills done and how many knowledge we updated. And we have total amount of KS drills during some time. This spike actually is quite fun. We had drills not so long ago. We, at the same time, well, during 2 days, we made drills almost on 300 of services. It's 30% of all of our services. And if you used Yandex Go during some time, like a week or two ago, and haven't seen any problems, it means that we are quite reliable. Also, since we shift lefted drills to teams, we needed to provide them convenient drills tool. It consists of several things. It's some UI to say, okay, you can type which service you want to drill, and it can validate you. Have you actually rights to do drills on these services? And basically, in our case, we have CLI to start drills, and we have a lot of visibility and notification about drills. We have alerts, we have Grafana annotations, we have, how to say it, we have records in calendar, we have different chats, we have different alerts. It's very visible, it's very convenient to use and update all parties that we probably will do something bad for their services. And the different tool is to find which service has tier. We have a platform admin, and in each page for each service, we can say, okay, this service has tier D, this service has tier A or B. For different business units, it's just to provide people with an easy way to receive information about that. And also, since we store everything in YAML file, we can run grab search during them and find all services and all different information about critical tiers for these services. So, of course, during this part, we struggled a lot. And our first big struggle was to define key business value. Luckily, we had at that moment experts who knew how system works and what is critical for them. And it's actually born from technical discussion. So incident managers decide that, okay, this is critical. They bring it to CTO, and CTO said that, guys, we have such conception. We think that it's core of a business value. Bring it to CEO, and said, okay, what do you think? And all agreed. So it's important here to keep update all parties, keep update business and the technical part, because often they are quite live in different worlds. But in this matter is important. Next big struggle is defining clear criteria. Also, we had experts, and we actually used the best judge to find which tier has which criteria. We misaligned with business units. We have quite different understanding what is tier A, for example, for Yandex Go, what is tier A for Yandex scooters, and it can be like by Yandex Go criteria, tier A of scooters can be actually C or something like that. And our biggest mistake that we assign tiers without maintainers involved. It's a very, very bad idea to do that, because if you ask person to do some for reliability, you need them to be in the loop about discussion how service is critical. We haven't done that, but luckily maintainers said that we are wrong, so now we shift left it to them complete ownership for criticality tiers. So what we got? Here are distribution for tier A microservices. We started it in early 22, and for 3 years we tried to keep it at the same level. But in last year we a little bit changed our reliability strategy, so it's improved, so it's increased, and also we removed monolith to several services, so now we have more critical services. It's distribution between our tiers, and we keep it by decision. So we have fewer high critical tiers, so we can add more resources to them. What you can get from this idea of criticality tiers? Well, you can get resource prioritization. You can heavily resource your tier A services by CPU, by memory, by different hardware. And probably you can even remove some resources from your tier D or lowest services, just to, if you have need. You can get clear rules for on-call. And it's another thing which is quite important. So for tier A and tier B, we say that, okay, guys, you're on call actually 24/7. And if you do that, if you go to our team, then you need to be ready for that. If you don't ready, okay, there are C and D tiers, and you can incident response only on business hours. It also can remove some misunderstanding with your teams. We got better observability, and you can also tell. We have a big dashboard of taxi health, Yandex Go health, and this is one of the panels in 2 different scenarios. Basically, on this panel, we can see health of all tier A services. By looking at it, incident manager can see that everything goes fine or something goes wrong, and quickly drill down to services to check if everything is fine. It allows us to early respond to incident if it's started to happen. And we got smooth onboarding. Basically, for your new SRE, you can say, okay, we have such conception. We have a tool to find critical tiers in our code base. So please find the new tier A services, and you need to look at them all the time. That's all. Here's my links. Please connect.